mass, the acceleration is inversely proportional to the mass, yes. So if we double the weight of the mass of the object, let's say 4 kg, the acceleration will be half, which is 2.5 meter per second squared, and also moving to the left. Another term involved when we discuss about this law, Newton's second law of motion, is weight. Weight means the reaction of the mass of a body to the force applied by the earth or any surface, which is known as gravitational force or gravitational acceleration, G. G was calculated to be 9.81 meter per second squared. And the difference between mass and weight is, mass is constant everywhere it is. For example, on Earth or on Moon. But weight of an object changes according to the gravitational force of a surface. Let's say Moon has 1/6 gravitational force of Earth. So if your weight here is 600 Newton, it will be 60 Newton on Moon. So that's about the second law. And now Rihanna will talk about Newton's third law of motion.
Newton's third law states that to every action there is an opposite and equally sized reaction. This means that at whatever direction you apply the force, there is an equal and opposite force applied in the opposite direction. An example of this is like a man sitting down. If it's got 100 kg mass and gravitational force of 9.81 meters squared per square thingy, and so his weight is 981 newtons going down on him, the force going up, a reaction force, is the same so that he stays still. Otherwise, he would decelerate downwards into the floor if there was no reaction force coming back up. Another example is if you were pushing against a wall, then the wall pushes back at you with the same amount of force so that the wall doesn't move, because otherwise you just fall through the wall. Like home and dog. A more complicated example, which shows that this force is not always just things staying still, is there's a picture of a balloon here attached to a straw with a pin in the middle. If you blow into the straw, you're pushing the force into the straw to to blow up the balloon. And then if you then stop blowing, the force comes out of the straw, the same like where it came at the same same direction and same amount of force. And then this way, this causes movement because the air coming out of the straw makes it makes the balloon and the straw pivot round the pin, like that. Now I'm going to choose Annabelle, who's going to talk about the applications.
Newton mechanics is also related to mathematics, as in the studies of the motions of objects and the forces that are exerted into the system. Isaac Newton found out the rate of changing momentum is equal to force. This is expressed in mathematics as follows. F equals d over dt times mv, which can also be written as F equals dv over dt times m. And because dv dt is the rate of change of velocity, we can also, well, that's also known as acceleration, so we can write F equals ma. Now we have an example. John was pushing Mary, who weighed 50 kgs with a